So in this video, we're going to touch very briefly on simple control flow and then move right into Python types. We're going to leave more complex types like strings, collections, and objects for later. We'll just be talking about the scalar types for now. Anyway, back to simple control flow. In an imperative language, you can do statement 1, statement 2, statement 3, and they get executed in that order, 1, 2, 3, just by virtue of 1 being higher in the file than 2 and 3. So this is going to output, hello world, how are you, goodbye. Sorry to bore you with that, but well, we're going to use it in the coming slides. The simple types in Python are pretty much int, which is mostly what you'd expect, except they're what a lot of languages call big ints. They can be quite large if you need them to be. Floats, which are basically IEEE floating point. They're all commonly implemented as a C double, so they're high precision. Bool is, of course, Boolean algebra, and or not, that kind of stuff, true, false. And none type, which is it has a single constant called none that we'll talk about in a bit. It tends to represent nothing or a sentinel value, but we'll also see there's a better way of doing that in Python. Common operations on ints and floats and other Python algebraic types are addition, subtraction, multiplication, modulus, and exponentiation. Exponentiation is, sometimes it's a hat, sometimes it's a star star. In Python, it's a star star. And then division, which is a little bit different from most languages. Slash represents float division, even if you're dividing two integers. So it's more like math, less like C. And then if you really do want integer division, you can use slash slash. Okay, so a couple examples of using int. No surprises there. Of course, 5 squared is 25. On example float literals, just note that they all have a dot in them, and scientific notation is the common e. So 1.5 times 10 to the 20th. Example uses of float. This illustrates what I mentioned previously about slash being float division even for integers. So 2/9 is actually 0.2 forever, and 12/5 is 2 because it's using slash slash, so it's integer division. Yeah. Okay, bool literals are true and false. They always have capital letters at the beginning. Common bool operators and or and not. Common operators returning bool. No surprises here, except not equal is not less than greater than, it's bang equal. Example uses of bool. No surprises here, I'll move on quickly. The none literal, as I mentioned previously, none is always capitalized. Example uses of none. You can say x equals none. It's usually faster to say y is none, and it works perfectly well. So you may as well just leave x equals none out of your Python vocabulary. Is kind of an interesting operator in Python. It tests object identity. It does not test equality. So is on none works well because there's only one constant of none type, which is called none. So testing it for identity works well. Python can also do is for some other types, like small integers, but that's an implementation detail that you shouldn't hinge your code on. You should use equals for integers and most things, except none and what we'll talk about a little later, just moments from now, actually, which is sentinels. Most languages do this with null or a null value, and you just test them for equality. Python has none. Again, tested with is. A better way of getting a sentinel is to say sentinel equals object left right, and it gets a known unique object. of in-specific value that you can test conveniently with is, so that you have a sentinel that you know is unique and you don't prevent someone from doing something like putting a none into your collection.